Ladies and gentlemen, you are welcome. So in this video, we are going to look at the dimension, or we are going to solve POST UTME first question paper in physics. The question says a force F is given by F is equal to AT plus BT square, where T is time. The dimension of A and B are, this is option A, dimension of MLT far minus 3 and MLT far minus 4, dimension of MLT far minus 4 and MLT far minus 3, dimension of MLT far 1, that is for the option C, and the dimension of MLT far minus 2, and then the dimension of MLT far minus 2 and the dimension of MLT far minus 0. So these are the options, and we are to get the dimension of A and B from this formula. So ladies and gentlemen, I think this is, we know in dimension we have, of course, fundamental quantities that have their individual dimension. Like for example, let me write solution here. Solution. So we know that whenever you have mass, it has a dimension of capital letter M. Time, it's represented with the dimension of capital letter T. Distance, displacement, and length, they all have capital letter L. So this is some of the basic fundamental parameters that we use in the dimension. So now we have this. So let's say we want to start with A. We want to find the dimension of A. So how do we do it? It is simple. We have to make one constant. So it is very important to start with the dimension to find the dimension of F first. F is force. And remember that force is mass times acceleration. And acceleration is equal to velocity all over time. And then velocity is equal to displacement all over time. So now, let's start with the dimension of velocity. So remember I told you displacement, time, and distance, they have the same dimension. So therefore now, the dimension of velocity is now going to be D, is represented as capital letter L, and then time is represented with capital letter T. So that means the dimension of velocity is now going to be LT raised to the power of minus 1. So this one is the same thing as this. Remember, if you could remember your law of indices, because this one, L all over T, is the same thing as 1 times L, is the same thing as L times 1 all over T. And remember, according to the law of indices, whenever you have minus, is the same thing as 1 all over. So therefore, this one is the same thing as, this one is the same thing as, this one is the same thing as L times T, L times T raised to the power of minus 1. So this one all over is something as this. So that is why if you multiply this and this, it is going to give us LT raised to the power of minus 1. So that is why the dimension of velocity is LT raised to the power of minus 1. Then what will be the dimension of acceleration? So since we know that the dimension of velocity is LT power minus 1, so I'm now going to say LT power minus 1 divided by another time, capital letter T. So that means we have LT. So this one is also the denominator. We are going to take it up. So we are going to have LT power minus 2. So therefore the dimension of acceleration is LT raised to the power of minus 2. So therefore to get the dimension of force is mass times acceleration. So the dimension of mass is capital letter M, and then acceleration is already here. So we have MLT raised to the power of minus 2. So this is the dimension of acceleration. So in physics, whenever you see this square bracket, it means dimension. Whenever you see this kind of square bracket like this, it means dimension of. So therefore, the dimension of force here is equal to mLT power minus 2. So therefore, we have the dimension of force. So how are we going to get the dimension of A here? So as I said, we are going to start with A. So therefore, if you are going to get the dimension of A, so B is going to be constant. So therefore, we now have F is equal to AT. And of course, plus, since B here is constant, so it's going to be 0 times T square. So therefore, we'll end up of having F AT. So to get that of A, we're now going to divide this by T. So this one will cancel this. So we now have A is equal to the dimension of force. We already know that is mLT raised to the power of minus 2, and we have T here, so divided by the dimension of another capital T. So A is now going to be mLT. This one, when it comes off, then we have minus 3. So we have the dimension of A here to be mLT raised to the power of minus 3. So then to get the dimension of B now, so A is going to be constant. So if A is constant, we now have F 0 times T plus B T square. So therefore, this one is now going to be 0. So we now have F is equal to BT square. So to get the dimension of B, we are now going to say T square by T square. So this one will now cancel this. Therefore, we now have B is equal to. So we know that the dimension of F is here mLT raised to the power of minus 2 divided by T square here. So T square is going to be capital T. The dimension of T is capital theta T square. So therefore, B is now going to be mLT raised to the power of, this one is 2, so it's going to be minus 4. So therefore, the dimension of A is mLT raised to the power of minus 4. So let's look at the option. And I think, ladies and gentlemen, clearly, if you can see option A here, this is the correct answer, because for A, we have mLT power minus 3. So we have mLT power minus 3. And for B, we have mLT power minus 4. We have mLT power minus 4. So this is the answer to this question. So this is a post UTME first question paper. So let's try and solve another question.